So we're going to solve this rational equation. Remember that first we have to find the LCD. And to do that, we're going to have to factor this one first. This factors into x minus 3 times x plus 1. So the LCD is actually x minus 3 times x plus 1 times x plus 2. So I take the left-hand side, rewrite it, with this LCD, and the missing factor is just x plus 2, equals. On the right-hand side, the first fraction with the LCD will be x minus 3 times x plus 1 times x plus 2, and here the missing factor we need is x plus 1 and x plus 2, and minus the last fraction is again over the LCD, x minus 3 times x plus 1 times x plus 2, and the missing factor here is x minus 3 times x plus 1. So since we have the common denominator on both sides, we can write our restrictions. X can't be 3, negative 1, and negative 2, and we can just use the numerators. Now this first numerator multiplies into 10x plus 20 equals the second numerator multiplies into 2x squared plus 6x plus 4 minus the third numerator, this one, multiplies into x squared minus 2x minus 3. Remember to put that in parentheses because we're subtracting. So when I distribute the subtraction, everything stays the same except this becomes minus x squared plus 2x plus 3. Combining like terms on the right side, the left side is still 10x plus 20. The right side is x squared and then plus 8x plus 7. So here we have a quadratic equation. So we want to write it in standard form. Make one side 0. Subtract 10x and subtract 20 on both sides. So we get 0 equals x squared plus 2x, or rather minus 2x, minus 13. So here we have this quadratic equation. We'll solve it over here. So this happens, this doesn't happen to be factorable. It would have been nice, but it's not. So I'll use the quadratic formula. I'll start using the discriminant. B squared minus 4ac is 4 minus 4 times 1 is 4 times 13 is 52 with a minus sign. So we get 56. Okay, and then the quadratic equation is x equals negative b, so that's 2, plus or minus square root of the discriminant over 2 times a, 2 times 1. If we simplify square root of 56, it's 4 times 14, so we get 2 square root 14 over 2, and that's 2 over 2 plus or minus 2 square root 14 over 2, which gives us 1 plus or minus square root of 14. So the two solutions are 1 minus square root of 14 and 1 plus square root of 14. And remember, none of them match our restricted values, so we're going to accept both of these so they can live in our solution set. For number 10, this is a radical equation, so we're going to isolate the radical by subtracting 2 on both sides. And once we isolate the radical, then we can square both sides. And here we have an important point that this is not reversible, so we have to check our values after we're done. Squaring the left side, we get 2w. Squaring the right side, w squared minus 8w plus 16. This is a quadratic equation, so let's write it in standard form. Make one side 0. Subtract 2w from both sides. So we get 0 equals w squared minus 10w plus 16. And this happens to be factorable into w minus 8 times w minus 2 equals 0. So w minus 8 is 0, or w minus 2 is 0. So w equals 8 or 2. Now we have to check both of these and see if they check out from the original equation. Let's check w equals 8 first. So on the left side, that puts 2 times w, or 2 times 8. On the right side, we have minus 2, or plus 2. And on the right side, we have 8 minus 2. So the question is, do these match? This is square root of 16 plus 2, and this is 6. Square root of 16 is 4, plus 2 is 6. That checks out. So 8 checks. Let's check the other possible answer, 2 for w. So again, plug this into the original. Square root of 2w, square root of 2 times 2, plus 2, question mark, equals 2, that's our w, minus 2. So here we get square root of 4 plus 2 equals 0. 2 plus 2 equals 0, and of course that is false. So 2 does not work. The only correct solution is 8. So that's the only number that's going to live in our solution set. Okay. Here we have to solve an exponential equation. To solve an exponential equation, you want to isolate the exponential part of this equation. Okay, so we're going to subtract 3. That'll give us 2 times 3 to the x plus 2 equals 14. Then dividing both sides by 2, we get 3 to the x plus 2 equals 7. Now we can't write 7 as an exponent of 3 easily, so we're going to take the logarithm of both sides. I'll use the natural log. So ln of the left side equals ln of the right side. Now for the left side, we're going to use the power rule to bring down this exponent as a factor. So we get x plus 2 times ln 3 equals ln 7. And now our goal is to isolate x plus 2. In order to do that, remember this is a product, so we can divide. X plus 2 equals ln 7 over ln 3. And then to isolate x, we're going to subtract 2 on both sides. So we get x equals ln 7 over ln 3 minus 2. And that's the exact solution. Okay? Now, to get the approximate solution, we're going to plug this into the calculator and get the exact solution correct to 3 decimal places rather. Rounded would be negative 0.229. And that's the answer. For this logarithmic equation, what we'd like to have is we'd like to have all the logs on one side and a number on the other side. So we'll add log x on both sides. So we get log base 2 of x minus 7 plus log base 2 of x equals 3. Then using the properties of logs, this turns, to write this as a single log, this will be log x minus 7 times x equals 3. Or in other words, log base 2 of x squared minus 7x equals 3. Now let's convert this to an exponential equation. The base is 2, and the exponent is 3. And the result is x squared minus 7x. In other words, x squared minus 7x equals 8. Now here we have a quadratic equation, so we're going to write it in standard form, x squared minus 7x minus 8 equals 0. And we can factor this. X minus 8 times x plus 1 equals 0. So either x minus 8 equals 0, or x minus 1 equals 0, or x plus 1 rather equals 0. The first equation gives x equals 8, and the second one gives x equals negative 1. Now again, we're going to take these numbers and we're going to plug them in inside the original equation. 8 minus 7 is positive, so it's acceptable. And of course, plugging it in here, 8 is positive, so it's acceptable. This is an acceptable solution. With negative 1, if we plug in negative 1 in here, we have a problem because log, the domain of log is only positive numbers. So the only solution that matches here is 8. And that's the only number that will be in my solution set.